To understand our world, we must look through the lens of why.
Have you ever looked up at the night sky and just felt this sudden, chilling sense that our understanding of reality might be completely, fundamentally wrong? Today, we're exploring a discovery that has literally sent shockwaves through the scientific community. We are talking about a dark, existential mystery hiding out there in the deep cosmos. A discovery that doesn't just tweak our timeline of the universe, it actively shatters it. Welcome to this explainer, where we're going to unravel the mind-bending enigma of a newly discovered galaxy that, according to absolutely everything we know about physics, simply shouldn't exist. Okay, let's dive into this. Imagine a team of archaeologists digging through a site from the Stone Age, right? They're carefully brushing away dirt from primitive tools and scattered bones. Now imagine that right in the middle of that ancient dirt, they unearth a fully constructed modern steel skyscraper. That visceral, almost sickening feeling of impossibility, that anachronism, that is exactly how astronomers felt when examining early data from the James Webb Space Telescope. We are looking at a cosmic structure that possesses a level of maturity and organization that absolutely defies the era of the universe it was found in. So, to really grasp why this is so baffling, we gotta understand what we're actually looking for. It's called a grand design spiral galaxy. These are mature, beautiful systems defined by a highly ordered, clear, and perfectly symmetrical structure. They feature sweeping, well-defined spiral arms wrapping around this really bright central bulge. Now, astronomers fully expect to see these in the modern, older universe. But in the universe's infancy, the period right after the Big Bang, galaxies are supposed to be chaotic, turbulent, clumpy, and irregular. They should be struggling to pull themselves together, colliding violently, definitely not posing symmetrically. And this brilliantly illustrates what we're actually dealing with. Meet Alaknanda. Named after the sacred Himalayan river in India, this glowing amber and charcoal artifact is a grand design spiral found dwelling in the deep cosmos. I mean, just look at it. It's perfectly formed. It has a visible disk structure that is unusually well settled. It has these elegant arms. It doesn't look like a chaotic baby galaxy. It looks like a wise, ancient cosmic elder, spinning serenely in a time when the universe was supposed to be nothing but violent, unstructured chaos. Now, the sheer scale of this discovery is staggering. This wasn't just handed to scientists on a silver platter. Two Indian astronomers, Rashi Jain and Yogesh Wadadekar, from the National Center for Radio Astrophysics, had to painstakingly comb through deep space data. They meticulously screened tens of thousands of cosmic objects, buried among 74,000 galaxies in the telescope's early data, to be exact. It's the ultimate needle in a cosmic haystack, a really rare exception that forces us to just stop and completely rethink the rules of the game. You might be wondering, how did we even see something so distant in the first place? Well, we had to use a trick of cosmic proportions. The James Webb Space Telescope actually utilized the Pandora Cluster, also known as Abell 2744, as a massive gravitational lens. The immense gravity of this galaxy cluster effectively bent and magnified the light of Alaknanda, which sits way, way behind it, practically doubling its brightness. Because of this natural magnifying glass, we were able to catch light that has been traveling for 12 billion years just to reach our lenses. Now, what's really interesting about this slide is the incredible detail we can see thanks to that magnification and Webb's infrared capabilities. On the left, in the near ultraviolet filters, you can see a distinct beads on a string pattern. These are active, furious star-forming regions perfectly tracing the alignment of the spiral arms. And on the right, the optical filters reveal the underlying highly stable disk. So to be clear, this isn't an optical illusion or a random clump of gas pretending to be a spiral. It is a genuine, structurally sound spiral galaxy. This whole thing sets up a massive collision between standard cosmology and reality. The standard model, known as lambda cold dark matter, strictly dictates that the baby universe was a hot, turbulent place. Galaxies required billions of years of cooling, merging, and gradual disk stabilization to even begin looking like a spiral. But the Alaknanda reality? It shows a shockingly stable, rotationally supported disk existing almost immediately. The angular momentum was preserved efficiently enough to allow this disk to settle way, way before our standard models say it should even be possible. In fact, if the standard model were a legal code, Alaknanda would be committing absolute crimes against cosmology. Let's look at the rap sheet. It is located 12 billion light-years away, meaning it existed just 1.5 billion years after the Big Bang. Yet it already contains 10 billion solar masses, making it roughly one-third the stellar mass of our modern Milky Way. And perhaps the most staggering fact of all, half of its stars formed in a mere 200 million years. To put that rapid assembly into perspective, Alaknanda is churning out stars at a rate 20 to 30 times faster than our own Milky Way is right now. We're talking about nearly 60 solar masses of new stars being ignited every single year. It is an explosive, sustained cosmic construction site operating on a scale that seems mathematically impossible, given the incredibly brief time frame of the early universe. So conventionally, astronomers frantically trying to explain this look to two primary processes for spiral formation. Step 1, smooth gas accretion, where cool disks grow steadily over vast stretches of time without violent disruptions. Or Step 2, gravitational tugs, where tidal disturbances from nearby smaller galaxies trigger a spiral pattern. Though, to be fair, these are usually short-lived. Now, because Alaknanda has a relatively small central bulge, it strongly suggests it grew via that first step, smooth accretion. But here's the fatal flaw, the catch that unravels the whole theory. The math, it simply does not add up. To form spiral arms via smooth gas accretion, standard models dictate that a galaxy needs about 1 billion years of undisturbed time. But the spectral data shows Alaknanda formed the bulk of its stars within a window of just 600 million years. It literally did 1 billion years of cosmic evolution in almost half the time. Which leads us to a deeply unsettling yet thrilling question. What if the standard models are just wrong? What if we aren't just missing a tiny variable, but our entire foundational understanding of physics and cosmic timelines is fundamentally flawed? This is exactly where the scientific narrative shifts from textbook astronomy into totally mind-bending, existential territory. Because if the standard model can't explain this skyscraper in the Stone Age, alternative theories are waiting right in the wings to take its place. One such alternative is the dead universe theory, or DUT for short. This fringe gravitothermodynamic framework proposes something radical, that our observable universe actually resides within the gravitational remnant of a prior collapsed cosmic structure. Look at these simulated stellar density profiles. DUT uses an oscillatory gravitational potential, essentially a cosmic rhythm of gravity that naturally generates massive, extremely compact cores right from the very start. It avoids the singularities of black holes and totally bypasses that slow hierarchical merging required by standard models. And within this dead universe theory is a mechanism called entropic quenching. This is a thermodynamic collapse process that perfectly explains how early massive galaxies like Alaknanda assemble so rapidly. The theory suggests that matter is pulled into these pre-existing, non-singular potential wells at incredible speeds. Then, once a critical entropic saturation threshold is reached, the environment naturally suppresses any further star formation. It explains both the rapid growth and the sudden stabilization, all without needing to invent hypothetical dark matter halos to make the math work. But DUT isn't the only theory trying to rewrite the rules. There's also the active galactic nuclei, or AGN, outflow theory. This posits that central supermassive black holes drive massive, large-scale outflows of gas that drastically accelerate galaxy growth and push matter outward to form disks. Interestingly, researchers have recently looked at local Gaia DR3 data right here in our Milky Way and found a small but significant outward expansion of 3 to 50 kilometers per second from our galactic center. If this kind of AGN-driven feedback was supercharged in the early universe, it might just explain how galaxies puffed up and matured so incredibly fast. So the crucial point is captured perfectly by this quote from the researchers studying Alaknanda. When reality contradicts expectation, reality always wins, and our models must adapt. Whether it's the dead universe theory, AGN outflows, or a completely undiscovered mechanism of cosmic evolution, the fact remains that Alaknanda is real. It's a massive testament to scientific humility. The universe is clearly far more capable of creating order, beauty, and complexity in its earliest, darkest moments than we ever gave it credit for. Which leaves us with a lingering, honestly haunting question to ponder tonight. Are we living in a universe that simply matured impossibly fast, an advanced cosmic child that rushed straight into adulthood? Or are we living in a universe whose fundamental physics, origins, and structures we've just entirely misunderstood from the very beginning? Alaknanda sits out there, 12 billion light-years away, spinning silently, holding the answer. To keep exploring the mysteries that break our understanding of reality, be sure to subscribe to Y-Lens. Keep questioning, keep looking up, and we'll see.
Why settle for shallow facts? Join the intellectual rebellion. Subscribe to Y-Lens now.